A trie, that's how this is pronounced right here. A trie, sometimes called a prefix tree, is a special type of tree used to store associative data structures. A trie stores data in steps. Each step is a node in the trie. This is often used to store words, since there are a finite number of letters that can be put together to make a string. A possible use case would be to validate that a word is in a dictionary. Each step or node would represent one letter of a word. So if you can see over here, this is an example of a trie. This word right here will be B-A-L-L, ball. The steps begin to branch off when the order of the letters diverge from the other words in the trie, or when a word ends. So you get the word B-A-L-L, but you also have B-A-T, bat. So the first two letters, B-A, are part of the word ball and part of the word bat. And then down here you can have doll, do, dork, and dorm. If you look at the red stars, that just means it's at the end of the word. So the word do, you can see it's the end of a word, even though there are still letters in other words after the O. So let's look at the information in each node from the code here. Each node is going to have keys, which is just a new map. And this is the ES6 map structure. It's kind of like an object. It has just key value pairs. And in these keys, the key value pairs are kind of like the name of a folder and a folder in a directory structure. So if you can imagine these all folders, in the root node there is the keys map that's going to have B, D, and S. And each of the key value pairs are the B, the name of this folder is the key in the map, and the value of that key is the folder B, the actual contents of the folder B. And so the D is the key in the map, and the value, the key value pair, the value is going to be the actual contents of the folder. Each node is going to have a list of keys, which is just a list of all the other letters that are inside that folder or inside that node. And then we're going to have an end data. That just means, is this the end letter in a word? So in this picture, all of the nodes with a star have end set to true, and all of the nodes without a star have end set to false. Now we just have a setter function, set end is equals true, is end, so it's just going to return true or false if it's the end of the word. So now that we've looked at each node in the trie, let's look at how the code to the actual trie is set up. So we're only going to have three functions. We're going to have add to add a word to a trie. We're going to have isWord to see if a word is a word in the trie, and then print. This is more of kind of like a helper function just to print all the words that are in the trie. So before I go through the code, let me show you how it would be used. We're going to create a new trie, and then you can add the words like this. And then after you add all these words, and these are the same words that are in this picture over here, you can check if it is a word. Is doll a word? Well, doll is going to be a word. Is door a word? See, we have the word D-O-R in the picture, but there's no star on R because door is not an actual word, even though those letters are in the trie. And then dwarf, well, check D-O-R, and then there's no F, so that's not a word. And then you can just print the whole thing like that. So if I run that, you're going to see in the console down here, true, false, false, and then you can see the whole list here. So let's go back up to here. First of all, we're going to create the root node, a new node, and then let's look at the add function. So this add function is a recursive function. So when you call it for the first time, you're going to put the entire word you want to add to the try, and that becomes the input. And here it says node equals this dot root. That means if you pass in a node, it will use that node. But if you don't pass in a node, it will just use this dot root as the default node. So if input.length equals 0, that means if we're at the end of the word that we passed in, we're just going to do node.setEnd and then return, and we're done with the add function. Else if, that means if there's more than 0 letters that we've passed into this add function, we're not at the end of the word. So first we're going to check if there's already a node with that letter that we're looking at. So this says if not node.keys.has. So let's say we're in the root node. Node.keys is a list of all the letters that that root node points to. So if it does not have a letter, input 0 would just mean the first character of the string we passed in. So if we pass in ball, this is just saying if there is not a node with the letter B here, then we are going to create a node with the letter B. Node.keys.set. Set is how we're going to create a new key value pair in the keys map. We're going to set it with the key to be the letter input 0. So input with 0 in brackets just means the first letter of the input we passed in. So if we pass in ball, the first letter is going to be B. And so remember, each key value pair is kind of like the name of a folder and the contents of the folder. The name of the folder is B. The contents of the folder are a new node. So then this is where it becomes recursive. We're going to call this.add, and we're going to pass in input.substr1, which takes the input and takes every letter after the first letter and passes it into the add function again. So if the word was ball, every letter after the first letter is ALL, so we're going to just pass in the letters all, and we're also going to pass in a node. Before, remember, we start with the root node. Now we're going to pass in this node, which is also the node we just created here. So we're going to set a node with the letter B. That would be the input 0. So now we're going to get the node with the input 0. That's the first character. So now we're going to run the add function, but instead of being at the root node, we're going to be at the node B. And then the else is just if there's already a letter by that name. So remember here, we added a node with the letter B, but if there already is a letter B, like for instance, let's say we already have the word doll, and we're going to add the word dork. If we're at the D, and the word doll is already in the try, and we want to add dork, well, O is already going to be in the try. So if O is already in the try, we're not going to create the O node. We're just going to add the new substring, which in this case would be ORK. We're going to add that to the node.keys.get at input 0, which would be the O node. So we're going to keep running through that until we've added the word to the try. And then down here, we're going to check if the word is in the try. So this is where the trie really performs. You can check if a word is in a dictionary much quicker in the trie than other data structures, because we don't have to check through every word, we're just checking one letter at a time. So we're passing in the word, we're setting the node to the root node at first, and then this is the loop that we're going to keep running through until we find the word. So while word.length is more than 1, while there's more characters to search in the word that we passed in, so if not node.keys.has word, this is saying we're going to check the first character in the word. So let's say we're on the root node. So if there is no key with the first character in the word, like let's say we pass the word tree, well, there's no T, there's no key with the letter T here, so we can return false. We quickly determine that that word tree is not in this trie because there's no word that starts with T. Else, that just means there must be a word that starts with that letter. So let's say we're looking for the word send. Well, if it does have the letter S, then we're going to do these two things. We're going to set the node, remember which used to be the root node, but now we're going to set the node to the node S. Because if we're going to look for the word send, we're setting the node to the S node, and we're going to change the word into the word minus the first character. So now we're just going to be looking for the word end instead of send. So we're going to go back up here. Now we're going to keep running through this. Now we're on the S node, but we're looking for the word end. And yeah, we'll find the E, we'll find the N, and we'll find the D. And now we go to this very last line. If node.key.has word, which would just be a single letter, because remember we keep taking the letters off. And so if it has the last letter of the word that we passed in, and it is the end, so is end, then we're going to return true. That word is in the trie. Else, we're going to return false. Yeah, so this last one was just the print function. This is kind of a helper function. And so we're going to create an array of every word, but right now it's just going to be empty. Then we're going to search. We're going to pass in, and we're going to search. If we don't pass anything here, it's going to set this to the root node. Actually, I bet we don't even need this. Let me just run that just to see if it does the same thing in the console. Yep. We don't even need to set the node to the root node because when we first called the search command down here, we already passed in this .root. So we're just going to pass in a node, and we're going to pass in a string here. If node.keys.size does not equal 0, that means there's still more letters to look through. So for each letters in the keys here, let's say we're on the root node, so the letters in the key would be B, D, and S. So for each of those letters, we're going to run the search command again, and then we're going to pass in node.keys.getLetter. That means we're going to pass in the node at that letter, so we would pass in the B node, and then we're going to add that letter to the string. At the beginning, the string would be empty. So do string.concat, that means we're going to add one letter, we're going to add the letter B. And basically, since this is recursive, it's going to keep going and keep adding each letter. It's going to keep concating each letter to the string until it's formed the whole word. And then see if node.isEnd, if we've gone to the last node in the word, it's going to do word.pushString. So that's our words arrayed. If we've gone to the last letter in the word, we're going to push the word onto the words array. Now else, that's the else to this if statement. If the node.keys.size does equal 0, Then we're at the last letter of a branch. If string.length is more than 0, we're just going to push that word on to the words array, or else returned undefined. And here's where we call that search function for the first time. So here's the search function, and then we call it for the first time, and it's just going to go over and over until it gets every word in the try. If words.length is more than 0, it's going to return that the words array, or it's going to return null if there's no words in the array. So that's a try.